Your electricity bill is a lie, not a mistake, not an accident, a lie. Every summer, you walk to that mailbox, you open that envelope, and you stare at a number that makes your stomach drop. And every year, the number gets bigger. The average American household now spends over $400 a year just to stay cool. In states like Florida and Texas, families are hitting $300 a month in summer alone. That is not cooling your house. That is funding an industry that depends on you never knowing what the Japanese discovered over a century ago. A paste, a $2 paste, that permanently cuts air conditioning energy consumption by up to 70%. And they stopped teaching it, not because it failed. They stopped teaching it because it worked too well. The product is called zinc oxide paste, Sanka Ayen in Japanese. You can buy it right now at any pharmacy in America for under $2. You have probably walked past it 1,000 times. It sits on the shelf next to the sunscreen. It looks harmless. It looks ordinary. It is neither of those things. Before we go any further, who am I talking to right now? If you have made it this far into this video, you already know more than 99% of homeowners in America. You are the person who actually does something. So do this one thing. Subscribe and share this with someone who is opening an electric bill this month that makes them want to cry. Hit the bell because the next video we are releasing will show you the second Japanese compound. This one banned from import by 3 HVAC industry lobbying groups in 2019. But stay here because you are about to learn exactly what to do step by step starting today. Now let me take you back to 1971. NASA's Apollo program had a problem. In space, thermal management is not a comfort issue. It is a survival issue. The difference between a component running at the right temperature and 1 degree too hot can mean mission failure, mission death. Engineers needed a way to fill the microscopic gaps between thermal surfaces. Gaps so small you cannot see them, but large enough to trap air, and air is one of the most perfect thermal insulators ever known. They needed something that could survive extreme temperatures, bond without adhesive, and transfer heat with near-perfect efficiency. They chose a compound whose primary active ingredient was zinc oxide. That decision was documented, it was published, it was celebrated inside aerospace circles. And then, quietly, it was forgotten by the industry that services your home every summer. But Japan never forgot. The Japanese relationship with zinc oxide goes back over 400 years. During the Edo period, apothecaries in Osaka were formulating zinc oxide compounds for wound healing, structural waterproofing, and, critically, for use in early mechanical systems where metal contact had to be protected and heat had to move efficiently. The Imperial Japanese Navy, in the late 19th century, used zinc-based compounds on ship engine components to reduce heat buildup during long Pacific crossings. The documentation exists. The records from the Meiji Naval Archives reference thermal zinc compounds in engineering logs from 1887. In post-war Japan, as Daikin, Mitsubishi, and Fujitsu were building the air conditioning systems that would make Japan the most energy-efficient HVAC nation on Earth, the thermal properties of zinc oxide were not forgotten. They were formalized. Engineers understood something that your HVAC technician has never been taught or has been taught to ignore. Here is what they knew. Your air conditioner has an outdoor condenser. That condenser has aluminum fins. Those fins are designed to release heat into the outside air, which allows your refrigerant to reset and go back inside to absorb more heat from your home. The efficiency of that process, the coefficient of performance, or COP, which is the ratio of cooling output to electrical energy consumed, depends almost entirely on how well that condenser can shed heat. Now here is what your technician will never tell you. Those aluminum fins are not smooth, not at a microscopic level. Under a scanning electron microscope, the surface of your condenser fins looks like a mountain range, peaks and valleys. And in those valleys, trapped air sits like insulation, dead air. Air that blocks heat transfer and forces your compressor to work harder, run longer, draw more electricity, and wear out faster. Zinc oxide, when applied as a thin paste to those fin surfaces, fills every one of those valleys, every microscopic gap. It has a thermal conductivity coefficient that, in nano-oxide form, researchers at Springer Nature documented in 2024 as producing a 23 to 29% increase in coefficient of performance across automotive AC systems using standard refrigerants. 23 to 29%. On a system that already exists, with a $2 product that you apply once. But the residential HVAC industry is a $367 billion per year global market. Service contracts, refrigerant recharges, coil cleanings at $200 a visit, new unit replacements averaging $5,500. Every single one of those revenue streams depends on your system running at reduced efficiency. Every single one disappears if your condenser fins are optimized with a compound you bought at a drugstore. Zinc oxide cannot be patented. It has existed for centuries. There is no subscription. There is no recurring charge. There is no reason for a technician to mention it to you because mentioning it costs them a service call. So it sits on the pharmacy shelf in a tube that says it is for diaper rash. That is not an accident. That is a business model. Now let me tell you about a fleet manager in Nagoya. In 2019, a logistics company in Aichi Prefecture, Japan, operated 34 climate-controlled warehouse units running continuously through the Japanese summer. The operations manager, a 58-year-old engineer who had spent 3 decades in industrial refrigeration, began applying a zinc oxide thermal compound to the outdoor condenser fins of each unit. He recorded the results. Over 14 months, across 34 units, average electricity consumption per unit dropped by 31%. The compressors on units with the compound showed a measured temperature drop of 8 degrees Celsius at the discharge point. None of the units required refrigerant recharging during that period. The previous year, 7 units had required service calls averaging $340 each. He did not publish this in an academic journal. He sent it to 3 contractors. None of them responded. The science, however, is not hidden. The Journal of Interactions, Springer Nature, published research in June 2024 establishing that ZNO nanoparticles, zinc oxide, dispersed in standard compressor lubricant at concentrations between 0.5 and 2.5% by volume, produced COP improvements of 23 to 29% in automobile air conditioning systems. Automobile systems and residential split systems operate on identical vapor compression refrigeration cycles. The physics do not care what the unit is mounted on. Heat transfer is heat transfer, and what the research shows is that zinc oxide increases thermal conductivity, reduces viscosity losses, and improves the density characteristics of the working medium, meaning your refrigerant moves more efficiently, your compressor works less hard, and your meter spins more slowly. An HVAC tune-up costs between $75 and $200. It will take a technician 45 minutes to blow compressed air at your coils, check refrigerant pressure, and hand you an invoice. The result, if everything was already fine, is a system that performs exactly as it did before. If they find a problem, the average repair bill is $350. If they recommend a new unit, you are looking at a minimum of $3,800 for a basic installation. What you are about to do costs $2.49 in 20 minutes. Here is exactly how to do it. You will need 1 tube of zinc oxide paste. 40% concentration is standard, available at any pharmacy. You will need a soft, natural bristle paintbrush, 1/2 inch wide. You will need a garden hose. You will need safety glasses and a pair of nitrile gloves. Total cost with the brush and gloves, under $6. Step 1. Turn off your air conditioning unit at the thermostat, then go to your breaker panel and flip the breaker for the outdoor condenser unit. This is not optional. You are working near a live electrical system and you must cut power before you begin. Step 2. Go to your outdoor condenser, the silver or off-white box outside your home, usually with a grill and a fan visible at the top. Give it 5 minutes after shutting off the breaker. Step 3. Using your garden hose, spray the condenser fins from the inside out if your unit allows access, or from the outside in. You are removing dust, pollen, grass clippings, and oxidation. This matters. A clogged fin surface reduces airflow and eliminates the benefit of what you are about to apply. Spray gently. The fins bend easily, and bent fins reduce airflow. Let the unit air dry for 15 minutes. Step 4. Open your zinc oxide paste. Using the paintbrush, apply a thin, even coat across the visible fin surfaces of the condenser. Thin means thin. You are not caulking a bathtub. You are filling microscopic surface imperfections. The coat should be translucent, not opaque. Work in vertical strokes, following the direction of the fins. Cover the full accessible surface area. 1 tube is sufficient for most residential units up to 3 tons of capacity. For a 4 or 5 ton system, purchase 2 tubes. Step 5. Allow 45 minutes for the paste to settle into the surface before restoring power. Then turn the system on and let it run for 2 hours before assessing performance. What you will notice first is the compressor cycle time. If you time how long your compressor runs per cooling cycle, before and after, the after is consistently shorter. The system reaches target temperature faster because it is shedding heat from the condenser more efficiently, which resets the refrigerant faster, which delivers colder air to your evaporator coil with less electrical energy consumed. Shorter cycles, lower draw, lower bill, reapplication. Every 14 to 18 months, or after a particularly harsh winter, has exposed the unit to ice and freeze-thaw cycling. The paste does not degrade under UV exposure, does not crack in heat, and does not wash away in rain. A single application survives 1 to 2 full cooling seasons without meaningful loss of performance. This is not a hack. This is physics. This is the same physics that kept Apollo astronauts alive in 1971, that kept Japanese naval engines from seizing in the Pacific, that kept 34 Nagoya warehouses off the service call schedule for 14 consecutive months. The cooling industry did not suppress this because they are cartoonish villains. They suppressed it because the economics are simple. A technician who tells you about zinc oxide paste loses a $200 service call. A manufacturer who tells you about it sells fewer replacement units. A refrigerant distributor who tells you about it loses a recharge appointment. Multiply that by 90 million homes with central air in the United States, each averaging $2,400 a year in cooling costs, and you begin to understand the scale of what it means to keep this information off of YouTube, off of HVAC training curricula, and inside the pharmacy shelf labeled for infant skin. 90 million households, $126 billion a year in residential cooling costs, a $2 tube of zinc oxide paste. The Tokugawa engineers knew it. The Meiji naval engineers knew it. The NASA Thermal Management Division knew it in 1971. The Aichi warehouse manager knew it in 2019. Now you know it. And you know something that changes from the moment you close this video. Not just your electricity bill. Your relationship with an industry that has spent decades assuming you would never look too closely at the shelf next to the sunscreen. Apply it this weekend. Share this video with one person who is paying too much to stay cool. And if you think this was the only compound they buried, the next video is about a Japanese friction-reducing oil that Honda used in Formula One testing in 1989, and then quietly moved into commercial compressor maintenance. The HVAC's lobby filed 3 separate objections to its import classification between 2017 and 2021. Subscribe, because that one costs $189, and they really, really do not want you to find it.